So in this question, we have to determine the conjugate of 4 minus 5 of I. So the conjugate can be represented as a bar over the complex number 4 minus 5i, and we'll simply replace I by negative I. So that makes it 4 plus 5 of I. So that is the conjugate of 4 minus 5i. Let's do another one. So here we have to determine the conjugate of 1 over 3 plus 5 of I. So let's take a bar over it. So as per the property that whenever we have z1 over z2 and we take the conjugate of it, that is equivalent to z1 bar over z2 bar. So we have 1 bar divided by 3 plus 5i over bar. Now the conjugate of 1 will be simply 1, and the conjugate of 3 plus 5i will be 3 minus 5 of I. But we have to convert it into the standard form, so to do that, we multiply the numerator and the denominator by the conjugate of the denominator, which will be simply 3 plus 5i. So that gives us 3 plus 5i divided by 3 squared minus 5i squared, which is equals to 3 plus 5i divided by 9 minus 25 I squared, which is equals to 3 plus 5i over 9 plus 25, because I squared is negative 1. So therefore the conjugate will be 3 over 9 plus 25, which is 34, plus I times 5 over 34 in the standard form. Let's do another problem. So we need to find the conjugate of the given complex number. So let us begin by first finding out the conjugate. So we have 1 plus I multiplied to 2 plus I divided by 3 plus I. So we take the conjugate of the overall complex number, so that reduces to 1 plus I times 2 plus I over bar divided by 3 plus I over bar. Now in the numerator, we can again use the property that z1 times z2, and when we take the conjugate of it, it's equivalent to z1 bar times z2 bar. So that would be equals to 1 plus I over bar multiplied to 2 plus I over bar divided by 3 plus I over bar, which is equals to 1 minus I times 2 minus I divided by 3 minus I. So this is the conjugate. Now we have to convert it into the standard form, so that would be 1 multiplied to 2 minus I times 2 minus I divided by 3 minus I. So that should give us 2 minus I times 2 is twice of I, minus I times minus I will be positive I squared divided by 3 minus I, which is equals to 2 minus 3I minus 1, as I squared is negative 1, divided by 3 minus I. So we have 1 minus 3I divided by 3 minus I. Now we are going to multiply the numerator and the denominator by the conjugate of the denominator, which is 3 plus I, and perform the multiplication in the numerator. That gives us 1 multiplied to 3 plus I minus 3I multiplied to 3 plus I divided by 3 minus I multiplied to 3 plus I. So we have in the numerator 3 plus I minus 3 times 3 is 9. So we have 9I minus 3I squared divided by 3 squared minus I squared. So that gives us 3 minus 8I minus 3 times negative 1. So we have replaced I squared by negative 1. Similarly, in the denominator, we have 9 squared plus 3 squared is 9. So we have 9 plus 1. So that finally gives us 3 plus 3, which is 6, minus 8I divided by 10, which is equals to 6 over 10 plus I times negative 8 over 10. Or in the simplified form, we have 3 over 5 plus I times negative 4 over 5. So this is the final answer. Let's move on to the next question. So we have 1 minus I divided by 1 plus I, and we have to find its conjugate. So let us begin by first finding the conjugate of 1 minus I divided by 1 plus I, or we have an over bar above. So we can reduce it to 1 minus I over bar divided by 1 plus I over bar, which will be simply 1 plus I divided by 1 minus I. Now we multiply both numerator and the denominator by the complex conjugate of the denominator, which will be simply 1 plus I. So that gives us 1 plus I whole squared in the numerator divided by 1 squared minus I squared in the denominator. That will be equals to 1 plus 2I plus I squared divided by 1 plus 1, where we have expanded the numerator by using the identity a plus b whole squared. So this finally gives us 1 plus 2I minus 1 divided by 2, which I have 2I over 2, and that is simply 0 plus I times 1. So this is the complex conjugate of the given complex number. Let's move on to the next question. So we have to determine the conjugate of 1 plus whole squared divided by 3 minus I. So let us first simplify the numerator. So we apply the identity a plus b whole squared. So that would give us 1 plus 2I plus I squared divided by 3 minus I, which is equals to 1 plus 2I minus 1 divided by 3 minus I. So the 1 and negative 1 will cancel out each other, leaving us with 2I in the numerator and 3 minus I in the denominator. Now we take the complex conjugate of the denominator, which is 3 plus I, and we multiply it to both the numerator and the denominator. So that should give us 2I times 3 plus I will be 6I, plus 2I times I will be 2I squared divided by 3 squared minus I squared. So 2I squared will be negative 2 plus 6I divided by 3 squared, which is 9, and I squared will be negative 1. So negative times negative will give us a positive. So that leaves us with negative 2 over 10 plus I 6 over 10, and we simplified it, and this should give us minus 1 over 5 plus I 3 over 5. Now we have to take the conjugate of this. So we haven't taken the conjugate yet. So the conjugate of minus 1 over 5 plus I times 3 over 5 will be equals to negative 1/5 minus I times 3/5. So in writing in the standard form, so we finally have negative 1/5 plus I times negative 3/5. So this is the conjugate of the given complex number. Let's go to the next question. So we will find the value of 3 minus 2I multiplied to the conjugate of 3 minus 2I. So we have 3 minus 2I times the conjugate of 3 minus 2I will be simply 3 plus 2I. So we can apply the identity a minus b times a plus b is equals to a squared minus b squared. So that would give us 3 squared minus twice of I whole squared. So that is 9 minus 4i squared. So 9 minus 4 multiplied to negative 1, where we have replaced I squared by negative 1. So that gives us 9 plus 4, and the final answer is 13.